What's up, everybody? We're back today for another lesson, and today we're starting off by solving some proportions. We got two sets of proportions here, and these are going to be a little different from what we have done in the last lesson. So I want you to start off, pause this video, take a second to try these yourself first, and then replay the video and see how I do it. So pause. Okay, cool. Hopefully you're back now. Hopefully you actually paused. If not, then you're just working the system, aren't you? But you're also not learning as much. You got to try things yourself sometimes. So let's jump into it. For our first one, we're going to use the method that we've been using, right? And that's our cross multiplication method. We're going to start off by cross multiplying. Sorry about that. 10 times x minus 3. And we've done something like this before. So when you multiply something like 10 times x minus 3, it's two terms for the x minus 3. When you multiply 10, you have to use your distributive property, right? So it's really like 10 times x minus 3. And this is scratch work right here, right? But what you could do is you draw your rainbows. That's what I like to call them. We do 10 times x, which will give me 10x, and then 10 times negative 3, which will give me negative 30. So one of our multiplications for cross multiplications is 10x minus 30. Then we're going to get our equal sign, equals, and then we're going to get our next one. I'll do in purple. We have x times 7, which is a simple one. You just do x times 7, which is 7x. Oops, purple to draw that 7x. There we go. And now we have to solve this. So when we solve this, we have to get our x's together. Now, I don't want to bring my 7x over, right? And the reason I decided that was because if I subtract 7x from both sides, we're going to have a 0 on this side. And then we're going to have to bring 30 over that way to get that over on the proper side. But what we could do instead, we could shorten this. And yeah, we're going to have to deal with negatives, but it'll be a shorter problem, less work for us. So we're going to subtract 10x on both sides. And when we do that, they cancel on my left side, and I'm left with a negative 30. Don't forget about that minus sign there. That keeps it a negative 30. And then 7 minus 10 gives me a negative 3x. And now notice how both are negative, right? So when we divide here, we're not just dividing by 3 to get rid of the 3. We have to divide by the negative 3. And same thing on this side. Divide by the negative 3. On my right side here, the negative 3x, the negative 3's cancel. On my left side, just the negatives cancel. Then we just have 30 divided by 3. So we get 10 equals x. Awesome. Now for my second one, once again, it's something that's a little different than what we've been seeing, right? So first of all, I want to start with my x times x. Uh-oh. I haven't seen this in a while. Now, this might be something that we forgot about. We have to be careful. X times x, that's the same thing multiplied by itself. When you do something like that, it's not going to give me 2x. What it will give me is x squared. Now, x squared or x to the power of 2, those are the two ways you say this, not x2, right? It's either x squared or x to the power of 2, right? So x times x gives me x squared. And on the other side, we do 2 times 8, and that's going to give me, let me color in the middle. Green. 2 times 8 gives me 16. So then how do we get rid of this square is what we have to ask ourselves. Well, the opposite of squaring something is taking the square root. So take the square root of both sides, right? And we're lucky here, right? Because right here, the square and the square root, they cancel, so we're left with x equals, and 16 is a perfect square. So when you take the square root of something, it's like asking yourself, hey, what times itself will give me this number? And we know that 4 times 4 equals 16. So the square root of 16 is 4. Awesome. Now, this was just a little bit of an algebra review to get us in today's lesson. We're going to be using tactics like this to solve some problems for proportions that we come up with. So today's lesson, as you can see, is called This Isn't Your Average Mean. Right? Little play on words there. And we're doing more with similar triangles today. We're going to see that. And we're going to be doing something called finding our geometric mean. We're going to do that a lot. But first, we're going to use the right triangle altitude similarity theorem, and we're going to use geometric mean to solve for unknown lengths. So let's talk about the right triangle altitude similarity theorem. That's a lot to say. But it states, if an altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So if you draw a line coming out of the right angle, right? It will create two triangles, right? So let's see it. So when that is used, we also going to have to do something called the geometric mean. So when we look down below here, we see our geometric mean in the process, right? So when we look, it says the geometric mean of two positive numbers a and b is the positive number such that x such that a over x equals x over b, right? So a over x equals x over b. This is the easiest way to remember it, where a is one number and b is another number. Now we're going to practice just finding the geometric mean on the next slide, just so we could get used to it. So let's look at it. The first one says, what is the geometric mean of 1 and 4? So what I like to do is label my two numbers a and b, and I'm going to rewrite that little formula. So we said it's a over x equals x over b. And now we're just going to plug in my a and x, right? So we'll get 1 over x equals x over 4. And now we just do our normal problem here, right? We just do it like a normal problem. So first of all, we're going to do x times x, just like we did in our do now. And that's going to give me x squared equals, and then we're going to do 1 times 4. And obviously, this is an easy one. Anything times 1 is itself. So this is going to give me 4. So finally, what we could do here, in order to get rid of that square, we do the opposite of that, which is called the square root. It's like a check with like a roof on it. And on my left side, the square root and the square are going to cancel, so we're left with x. And on the right side, what number times itself gives me 4? 2. Because 2 times 2 equals 4, so our answer here is 2. So the geometric mean of 1 and 4 equals 2. Now, I want you guys to be careful, because this doesn't mean like, hey, you multiply them and then you divide it by 2, right? Because if you did that for this case, it would give you the same thing. But we're going to see in a moment that it's not going to work for every case, right? All right, let's do this next problem. In this problem, it says, what is the geometric mean of 15 and 3? So once again, the geometric mean is going to be our x variable. The way we set this up is we take one of these numbers, start off with 15, and put it over x equals x over our other number, which will be 3. Remember that the geometric mean has to show up twice here, once on the bottom and once up top. It doesn't matter where we put our 3 and our 15. It's just as long as we have the x or the geometric mean. Sometimes our geometric mean will be given to us, and our x will be one of these numbers. So the geometric mean just has to show up twice, once up top, once down below. And then once we do this, we do the same steps as the last problem. So first of all, I'm going to multiply my x times x, and that's going to give me x squared. Now remember, that's x squared, not 2x. There's a difference between those. And then we get 3 times 15, which is going to equal 15 times 15, or 15 plus 15 will give me 30, plus 15 will be 45. Now, thing that we need to do, and a lot of you I know are using your calculator on your phone. So the thing that we need to do is figure out, how do we do the square root? The last one was easier because when we take our square root on the last one, what we could do is just say, hey, this is a perfect square. 2 times 2 equals 4. But there isn't a whole number that multiplies by itself to give me 45. And that's what this square root is, right? So on my left side here, we're fine. Square root is just, they cancel here, right? We're left with x equals, and on my right side, we have to take the square root of 45. In order to do this on your phone, I have an iPhone, and I believe it works on Android too. You just turn your calculator sideways, and there should be a square root button. The button will look like this. Here, I'm going to write button, and it should look something like this. It should be a square root symbol with an x in it, and a little 2 here, right? That's what the button should look like. So you type in the number, then you press that button, and it will take the square root. The square root of 45, and we're going to round to the second decimal place, will be about 6.7. It should be a 0, but we're going to round it because the next number is 8, so we're going to round it to a 1. And that's how we do our square root. And there we go. We got our geometric mean of 3 and 15. Awesome. Now, let's look at our right triangle altitude hypotenuse theorem. Wow, what a mouthful. Right, so as we said before, this theorem states the measure of the altitude drawn from the vertex of the right angle of a triangle to its hypotenuse is the geometric mean between the measure of the two segments of the hypotenuse. So what does that mean? What that means here is if we have A and B, then this segment here, DC, that dotted line, DC, is equal to A over X equals it's equal to X, where A over X equals X over B. So it's that geometric mean, right? That's what this is saying. All right, let's look at our next theorem. Right triangle altitude like theorem, another mouthful, right? So it says if the altitude is drawn to the hypotenuse of the right triangle, each leg of the right triangle is the geometric mean of the hypotenuse and the segment of the hypotenuse adjacent to the leg. So we don't actually need the altitude for this one, but it cuts it into segments, the hypotenuse into segments that we'll need. So let's label a couple things here. Let's call this side A, call this B, let's say this is C, and this will be D. And then we have this whole entire section, a whole entire hypotenuse here, right? We'll call that F, right? And I know it's actually I could write it on the block. F, right? So with that in mind, we have to find A and B. We're assuming that we're given C, D, and F. In order to find A, well, A is going to be the geometric mean, but we're going to use C over A equals A over this whole entire thing, F, right? So if we're finding this leg of the big triangle, we're using this portion here of the hypotenuse and the entire hypotenuse. Whereas if we want to find B, Now b is going to be the geometric mean. So it's going to be kind of doing the same thing except for on this side. So up top we'll have d over f. Sorry, just kidding. D over b. Sorry, I was looking at the wrong letter. Equals b over f. So the segment over our leg, and then our leg over the entire hypotenuse. And this is our right triangle altitude leg theorem. So now let's see these two theorems in work and how we could actually use them. Then maybe it'll help us figure them out a little more. So this is a problem in work, just kind of showing you the idea that we just talked about. This is using our first theorem, right? So in it, we have the altitude, and then we have the two segments of the hypotenuse, which you could see down below. One of the segments is 8. Yeah, actually get my pointer out. One of the segments is here, 8. That's one segment. And our other segment is x. We want to find x. So this one is actually using the geometric mean, but we don't have to find the geometric mean. So what they do is they set it up. They know that it's going to be 8 over the altitude, which is 12, and then 12, the altitude, over x. So then what they do first is they simplify to make it easier, and then they'll cross multiply, right? So we'll get 2x equals 36, and then they divide both sides by 2, and they get x equals 18, right? Now let's do our own problem. All right, so let's see this problem in action. So in this problem, it says we want to find x, y, and z. So we're going to have to use all three theorems here. So let's start out by finding x. And this is using our first theorem that we talked about. So I'm going to say part A. Oops. We're going to find, forgot the n, find x. There we go. In order to do so, we have to think about which theorem we're going to use. Now we're going to use our hypotenuse altitude theorem. And in that theorem, it says our altitude is the geometric mean of the two segments of our hypotenuse. So 10 and 5. And the way we're going to write that is we're going to take one segment. So I'm going to start with 10. I'm going to put that over my altitude. And then we're going to say that altitude again up top here over my other segment, which would be 5. And then all we have to do is solve this. So we'll cross multiply and solve it. We're going to say x times x. That's going to give me x squared equals, and then 10 times 5 will give me 50. Now, once again, in order to get rid of that square that's there, we take the square root of both sides. And when we do that, I'm not going to lie to you, got to plug it into a calculator. So we get x, it's going to cancel out here, and we're just left with x. And in my calculator, if I put in 50 and I take the square root of it, it's going to give me a number, and we're going to round to the second decimal place. It's going to give me 7.07. There is my answer. Awesome. That's A, and we just found X. I'm going to write 7.07. I like filling things in on my triangle, so I know that I did it. Next up, we're looking for, let's go to Y. Stay in alphabetical order. So B, we're going to find Y. And in order to find Y, now we're using a different theorem here, right? And this theorem is our second one, right? And what we need is we need this whole chunk. We need to find the distance of this whole entire thing, which is really just like 10 plus 5, which is going to equal 15. So for this one, what we could do is Y is going to be our geometric mean again. We're going to use the chunk closer, which will be here. We're going to say 10 over Y equals Y over 15. So the chunk over my missing leg, and the missing leg over the entire hypotenuse. And we cross multiply again. So we get Y times Y gives me Y squared equals 10 times 15 will give me 150. I take the square root on both sides, and I'm going to once again have to plug that into a calculator. So we get 150, and we take the square root of it. That's going to give me 12, and once again, rounding to the second decimal place. So we get 12.25 we're going to get. All right, so that's our second answer here, 12.25. And we still have one more thing to find out. We have to figure out z. So for part C here, we're going to say we're find z. Ugh, that looks like a 2. Find z. There we go. That looks more like a z. And we're going to use the same idea that we just used, right? But for this triangle that's on the right over here. So z is going to be the geometric mean, right? So we can set this up as the small chunk, which is going to be 5, over my leg, which is z, equals my leg, once again, z, over the entire hypotenuse, which is 15. And once again, cross multiply. We're getting pretty good at this now. Z times z gives me z squared. Now don't get your z's and 2's confused. Equals 5 times 15, which is going to give me 75. We take the square root of both sides. It cancels here, and we're left with z equals, and we have to find the square root of 75, which is going to be, if we round to second decimal place, 8.66. There we go. Box it off. I'm just going to write it in my little thing over here, 8.66. And there we go. We found all of our answers. Now, don't forget, if you're confused, ask your teacher. If it's me, it's Miss Harris, or if you have another teacher, don't forget to ask us for help. So now we're using the geometric mean. Talked about that. Let's do some more problems. Now this problem, once again, now only has one variable that we need to find, right? So this is using the first theorem. This is going to use our first theorem in order to work on it. So once again, I suggest pause here and try setting this one up yourself, try solving it yourself, and then play the video again and see how my work goes. If you truly don't know, then you could keep playing, obviously. So let's jump right into it. For this problem, we're going to start out and we're going to say, hey, which of these things, we're only given 3 things. We know we have to we're going to use our geometric mean. Which one's going to be the geometric mean? Well, our altitude in this problem will be the geometric mean. So x. So we could write this as 4 over x equals x over 9. X times x. Once again, x times x gives me x squared. And then 4 times 9 will give me 36. We take the square root of both sides. And once again, you guys can plug this into your calculator. But for me, I know that 36 is what we call a perfect square. So when I take the square root of it, or when you ask yourself, hey, what times itself gives me 36, that answer is going to be 6. So x equals 6. There we go. Now the hardest part is setting up our geometric mean, right? So you have to just know which one of these is going to be my geometric mean, and that's x. So we need that twice in those ratios. Awesome. So let's go again. Now, the thing is, x won't always be your geometric mean, the one that you have to write twice. Sometimes it'll be another number, which will make our lives actually easier. So, for instance, in this one, 8 is our geometric mean. Our geometric mean will always be this altitude, that line cutting through here, when we're using our 2 segments that create the hypotenuse, which x and 4 is. They're the 2 segments creating our hypotenuse. So the way we're going to write this one is x over 8 equals 8 over 4. Now notice 8 is the one that we have twice here because that's the geometric mean. And now we solve. We get x times 4, which will give me 4x, equals 8 times 8, which will give me 64. Now, for this one, instead of taking the square root, because obviously we don't have a square there, all we have to do is get rid of that 4 next to my x. So in order to do that, we just divide both sides by 4. And when I divide both sides by 4, some of you may already know this, it gives me 16. And there's my answer for x. So guys, just a reminder here, if you are struggling with any of this and you have a teacher to ask, make sure you ask that teacher, whether it's me, because you're one of my students, whether it's Miss Harris, because you're one of her students, or whoever your teacher may be if you're from a different class. Make sure you ask your teacher for help, and trust me, they'll be more than happy to help you. All right, next problem. So for this one, we're going to have to use our other theorem here. So for this theorem, remember, we need this whole chunk here. So what we could say is we need to add these two sections. We get 4 plus 20. That's going to equal 24. And that's the number we want to use. That's my whole hypotenuse of this big triangle. We're also going to use this, this chunk here. And remember, this leg, x, is going to be my geometric mean. So the way we're going to write this is we're going to take the leg. We're going to say 20 over x equals x over 24. And once again, we are going to cross multiply. So when I cross multiply, we get x times x. And that's going to give me x squared. And then we're going to get 20 times 24. Once again, let me pull out my trusty dusty calculator. So 20 times 24 gives me 480. And then, as we've been doing, we take the square root of both sides to get rid of that square. They cancel. We're left with x. And we take the square root of 480. And that's going to give me 21.9. So x is equal to 21.9. Actually, sorry. Let's keep it consistent. Round to the second decimal place. The second decimal place is technically 0. But after that comes an 8. So it's really going to be 21.91. I apologize about that. So 21.91 is my next problem. And our last one, I'm pretty sure, last problem here. They already give us the big chunk. So all we have to do is set up our geometric mean, right? Our proportion, that was the word I was trying to think of. So remember, our geometric mean is going to be x here. So we could say the segment 2 over x equals x over 8. And once again, cross multiply like we've been doing. Oh no, I hit the wrong button. There you go. And we get x times x, so that gives me x squared. We get 2 times 8, which will give me 16. And finally, take the square root of both sides. And that's going to give me x equals 4. Beautiful. So now, remember, these aren't always going to be the easiest problems, and that's the end of our PowerPoint, but practice, practice, practice will help it stick into your brain and then also help you learn it and understand it better. So as always, if you need help, ask your teacher, whether I'm your teacher and you're in my class, whether Miss Harris's class, or you're from a different school, maybe from a different city, maybe from a different state, maybe from a different country. If you need help, ask a teacher or drop a comment down below. Thank you for watching, and I'll see you next lesson.